Hello class and welcome to today's lesson on 1-3, talking about combinations. So today's objective, students will be able to know how to count combination problems. And our essential question is, what is the difference between permutations and combinations? So to start with, combinations is the formula for finding the number of ways to pick a small group R out of a large group N, right? If you think back to permutations, right? Same process there. The one difference here is use when the order doesn't matter. Use when the order doesn't matter. We show this as NCR. Right? In our calculator, we'll have NCR. So we'll go over that here in a little bit. Making sure, one quick thing, right? N is always our larger number. So we got to make sure, right? Bigger number is always our N. So example down here, it says, picking a group of 4 to work together from a class of 30. First thing I want us to notice is that word right there. We're going to focus on that here in a sec, but right, you see a word like group, that should tell you right away we're doing combinations. So, right, we've got to figure out what our N is. Our N is going to be the large group, so that's the whole class. And then we're taking a smaller group of students out of it. So in our calculator, we type in 30 NCR4. So I'm going to show us real quick on our calculator, and then, so if we pull this up here, so I'll clear this out. So if we go here, right, we have to type in 30 first. So type in 30, then we're going to hit math. And we're going to arrow over to probability. And then notice we want NCR. So I'm going to arrow down here and hit enter. And now my calculator might look a little different than yours. But right now it's just asking for what is the R value. In this case, it's 4. And so now I hit enter one more time, and it gives me my answer of 27,405. So I'll open that up here. So again, that was 27,405 ways. And so like I was talking about before, if you see the word, you see group, or you see team, or maybe you see the word committee, those might be great ones to look for that go, oh, okay, I'm doing a combination problem here. So if you ever need to, please feel free to pause the video if you need a sec just to catch up. So first one here, we're just going to write out the problems. We're not actually going to solve the numbers on these ones. If I wanted to make a group of 4 out of a class of 39, how many ways could I do this? We'll write my N value, my big group is 39, and then my R value is going to be 4. Right, then I have my answer right there. Second one says, if I was forming a committee of 5 people out of 30, how many ways could I do this? Right, 30 is our big group, 5 is the small group I'm taking out of it, and then I solve that by plugging that into our calculator here. And then last one here, it says if I was picking 4 people to go on a field trip out of a class of 25, right, 25 is my large group, 4 is the small group I'm taking out, and then we get our answer. So continuing on here, this one we'll write out the actual answer here for it. It says, how many ways can you pick a 5-card hand out of a 52-card deck? Right, we want to start with, okay, what's of those 2 numbers, which ones are N, which ones are R, right? N is always that larger one, the big group. So we have 52 NCR 5. All right, if we're to plug that into our calculator, this is telling us, or gives us an answer of 2,598,960. And so what this is saying is that you're taking your 52 cards, how many different 5-card hands could you get? And again, being a combination, this means the order does not matter. It doesn't matter whether maybe you got an ace, whether it was the first card or the fourth card. It's just that group of 5 cards. We're saying how many different groups are there? There are 2,598,960 different ways to do that. So right here, this is a challenge problem. So it's going even more in depth here. It says how many ways can you get a pair of aces in a 5-card hand? The way you set this up, it has a couple pieces to it. First, you have to talk about, okay, I'm going to pick an ace. That's our first step. Well, how do I choose that? Well, there's 13 different types of cards, and I'm choosing one of them. Then what we do is I want to have 2 of those cards, right? I want a pair. So I'm going to do 4 NCR2, right? Of my 4 aces, I want 2 of them in my hand. Now the next piece I have to worry about, okay, well, what are my other cards? Well, right now I don't want any aces, so there's going to be 12 choices. NCR, and I need 3 other cards in my hand, right? Because we always have a 5-card hand. So 12 NCR3, and now final part is of those cards, I don't want any of them to be pairs. So each of them are 4 NCR1, because I have 4 of some card and I only want 1 of them. So a long process. Again, this is a level 5, right? When we talk about all of our different level type questions, this is a level 5 question. They actually have classes in college that are all about probability of playing cards and things like this. And so this is a challenging question, but a fun one to look at. And so if we're actually to do that, we can look down here at the answer. That explains it right here. So the probability is about 0.422. And the way we could find that total, right, is by multiplying all of these values together. So again, fun challenge problem, not one that you need to exactly know how to do, just a fun little one. This one we're going to skip as well. We don't need to worry about that. This just showing us some fun probability of some decks of cards and the types of hands that you can get, right, how often it happens, the probability of it happening, and then the odds. We're going to play around with a lot of things like this with decks of cards in this class, and so this is kind of a fun little thing to look at. So last couple pieces here. This one, right, permutation combination, or math called counting principle, right, we call it the multiplication counting principle. So to start with, right, we're just going to choose which of the 3 things is this example. So number 1 says creating fruit salad with 3 types of apples, 2 types of berries, 2 toppings, right? Step 1, step 2, step 3, we have 3 times 2 times 2, right? That's using our multiplication counting principle. We look at the second one here, it says top 3 out of 11 runners competing in an event. Notice right here, order matters. So this tells us right away that is permutation. Permutation. Number 3, picking a group of 4 people, right? That should shout right exactly what we're doing. A group of 4 people from a class of 20. This is going to be combination. And then placing 5 books on shelves of a library. We have 5 books. We're putting them in a certain order on the shelf. This is going to be a permutation problem. And it's kind of a silly one. We'll get into more detail about it, but it's 5 NPR 5. Also, it could be written as 5 factorial. So that is it for today's lesson on 1.3, talking about combinations.